7.6 homework. Let's see if we can get through this. Let me move away a little bit. Let's go ahead and make sure we write our names now and whatever period you're in. Make sure you put your first and last name, please. Your first and last name. I don't have all your last names memorized yet. Okay, so 7.6 was all more about rate. Let's give ourselves some notes. Let's use a little bit of metacognition. We know that the rate is the change in y, or the change in the y-axis, over the change in the x-axis. Remember, the triangle means change. Okay, so let's see what we got here. Fill in the missing information about these skates recorded by a student. So instantly you should start thinking about the skating parts, moving away from the motion detector, distance, so on and so forth. Karina. Fill in the table, create the graph, or find the rate. We have to assume that the graphs are linear. What does linear mean? Well, it means a line. It means a straight line, actually. So if we have a straight line, we know it's going to be a constant rate. So that one word linear lets us know that it's going to be a constant rate. All right, so let's see. How fast was he skating? Well, remember, how fast is speed? Speed is rate. So we have to find the rate. From 6 to 5 feet, I went down 1 foot. From 0 to 1, 1 second passed. So you put -1 foot over +1 seconds, and you get a rate of -1 feet per second. So my rate's a -1 foot. So let's see, another second went by here. I went from 1 second to 2 seconds. So if 1 second went by, I went down 1 foot. So if I was at 5, I went down to 4. Another second passed. I went down another foot, so I went to 3. So let's see, if we start at 0, 6, we need to label our axes. So ask yourself, what should go down here? Well, I know it's the x-axis, and the x variable is always on the left-hand side. So this is time in seconds. This is my y-axis, and so this is feet. So if 0 seconds have passed, that means I'm at 6 feet away. 1 second, I'm at 5. 2, I'm at 4. 3, I'm at 3. Now let's keep this going because we know the rate is -1 foot per second. So come over 1 more second. We were at 3, now we're come down 1 to 2. Over to 5, come down 1. Over to 6, come down 1. And so you should have a graph that looks like that. All right, next one. They didn't give us anything in the table, but they did give us the graph. So we can create the table from the graph. So let's find some points. I see a point right there. Follow your line down. I see a point right there. What I'm doing is following the bold line and finding where it crosses perfectly those little T's in the background. So come down again right here, come down again right here. So that should be able to fill up our table. So this is 0 seconds and 7 feet. So 0 seconds, 7 feet. This is 2 seconds, so 2 seconds, and this is 6 feet. This was 4 seconds, and that matches up with 5 feet. And this is 6 seconds, 6 seconds and 4 feet. All right, so let's find the rate. So we've got 7 to 6, we went down 1 foot. 0 to 2, 2 seconds passed, which means I went down 1 foot, and it took me 2 seconds. So we can actually write this rate 2 different ways. We can write that the rate is -1/2, 1 foot per 2 seconds, or we can write -0.50 feet per second. Either way, it's exactly the same. -1/2 is the same thing as -0.5. So we've got a line going down that makes sense. All right, so let's take a look here. If we look at the seconds, seconds are going by. look at the distance. I'm going from 1 to 5. So instantly, should my rate be positive or negative? Should be positive because we're going up. Okay, so if we have, let's try it a different way too. So 1, 1, let's go ahead and graph it. 1, 1. Here are my seconds. Here are my feet. So 1, 1 we graph. The only other one we know is 3, 5. So 3 up to 5. So if I connected those, whatever my 2 is has to line up. So take a look at this. 2 and 3 matches up perfect. So there's an alternative way to do it. You can make the graph and then fill it in. We've got 3 and 5, and then we've got 4. Let's see, if we were to extend this. Oh, I think I made that a little crooked. If we were to extend this, this is where a ruler might help. I see 4 matches up with 6. I might be a little off there. Let's see. Yeah, I think my graph's a little off. If that happens, it's easy enough. Let's find the rate, and then we can figure out 4. So from 1 to 3, I went up 2 feet. 1 to 2 seconds, I went up 1 second. So it's positive 2 feet over 1 second. So my rate is 2 feet per second. Okay. So my rate's 2 feet per second. So each second that passes, I should go up 2 feet. So if I went from 3 to 4 seconds, that's 1 second. Go up 2 feet, so that's 7. So my graph should have been at 4, 7. So I was a little off. Should have been a little further up. Now 2 feet per second, we know it's going away. Is that really fast or really slow? I'd have to say really fast because look how almost straight up and down it is. All right, next question, moving right along. What are the differences between a positive rate and a negative rate? Well, positive rates go away or up. Negative rates go towards the ground or down. All right, next one. What does it mean for an elevator to have a rate of 1.5 floors, 1/2 floors per second? Well, it's a little tricky to figure this out when it's written like this. If it's 1.5 floors per second, we know it's 1 floor per 2 seconds. This makes it a little bit easier to decipher. That means you're moving 1 floor up, and it takes you 2 seconds to do so. So that's a pretty slow rate. It takes you 2 whole seconds just to get to 1 floor, or 1 floor up. All right, what do we got left? One more page and then the staying sharp. Let me get you started on this, and then I'll let you finish it on your own. All right, the graph shows the data collected from a skateboarder's skate. Fill in the missing data, and then use the table to follow the answering questions. All right, so at 0, I'm at 6. Let's go ahead and label it. At 1, I'm at 4 feet. At 3, I'm at 2 feet. At 6, I'm back up to 3 feet. And 10, I'm all the way up at 7 feet. All right, easy enough. So let's take a look at these. This is a negative rate. This is a negative rate. This is a positive rate because it's going up. And this is a positive rate because it's going up. So at 3 seconds, what happens? Well, I turned around because I was going down, 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 then I went up, up, up. All right, so find the skateboarder's average rate between 0 and 1 seconds. Well, 0 to 1 seconds is 1 second here, and I went down 2 feet here. So you have negative 2 feet over 1 second, and so your rate is negative 2 feet per second. Remember that negatives 2 a pretty fast rate, so take a look at that first section that we're talking about. That's pretty straight down, so that makes sense. All right, I'm going to go ahead and let you finish B, C, and D, and E. Now, write a story to describe the skaters. I'm going to start the story for you and you finish it. So this skater starts 6 feet away. For 1 second, in the next second, he comes down 2. So there's the beginning of your story. The skater starts 6 feet away, and in 1 second, comes down 2 feet. And then you can handle the rest. Quick thing on the staying sharp. There's one thing you might not understand here. This is called an area model. What happens is this number and this number multiply to get this. This and this multiply to get this. So let me show you. 10 times 2, there should be a 20 here. 10 times what is 100? What number would have to go here? 10 times what equals 100? Well, it'd have to be 10. All right. Now look here. 2 times what has to equal 12? 2 times what equals 12? Well, it has to equal 6. Good. And you can fill in the rest. All right. See you in class.